All right, today we're going to be talking about Chapter 11, Lesson 8. It's called Similarity and Transformations. So, when we are dealing with similarity and transformations, similarity means that they are the two shapes are the same shape, but not necessarily the same size. Now, what's really important to remember, just because they're not the same size does not mean that their dimensions are going to be whatever you want them to be. So when we're talking about similarity, the important thing is that the ratios of corresponding sides are equivalent. That's really important. In other words, we're looking for a scale factor. We're going to be looking for a scale factor. Now, just like with congruence and transformations, we can still use translations. We can still use rotations. And we can still use reflections because these keep the shape. The only difference now is we can use dilations because this changes the size by a scale factor. So all of those can be used. And in fact, we can use any combination of the four. So example 1, it says determine if the two triangles are similar using transformations. First one you should always do is dilations. The reason why is because the important thing when similarity occurs is that ratios of corresponding sides are equivalent, which means they're the scale factor. So if we do dilations and we find that there isn't a common scale factor, we can stop right there because then they're not similar. So let's look at the small triangle, try to get it to the big triangle. So this is 3, that is 4. This right here is 1, 2, 3, 4, and this is 1, 2, 3, 4, 5, 6. Corresponding sides, HK and EG are corresponding sides, so that'd be 3 to 4. And that'd be 0.75 as our scale factor. Next one, KJ and GF. That's 4 to 6. And that's a scale factor of 0.6 repeating. These scale factors aren't the same. Which means that these are not similar. And the reason why is because ratios of corresponding sides are not equivalent. And that's the important thing to remember. Now, if they are equivalent, we would then have to figure out how we would get the smaller triangle to be mapped onto the larger triangle. But right now, it says ratio of the corresponding sides are not equal, so we can stop because they are not similar. Example 2, determine if the two rectangles are similar using transformations. So again, let's do the same thing here. AB, that's 3. B down to D is 1, 2, 3, 4, 5. EF, that looks like it's 1.5. And from F to C, it looks like it's 2.5. So let's look at corresponding sides. 1.5 and 3 to get from FE to AB. Sorry, EF to AB. Be 1.5 to 3, and that would be a scale factor of 0.5, or a ratio of 0.5. Next one, 2.5 and 5. That would also be a scale factor of 0.5. So these are the same. Which means that they are similar. Now we just need to figure out which kind of transformations we need to use. So if we want to get from this one to this one, the ratio was 0.5 from the small to the big, but if I want to get from small to big, it means I'd have to do what times 1.5 gets you 3? Well, scale factor would be 2. To get from the small to the big. Next, we'd have to do a 90-degree rotation clockwise, because we'd want to get this to look up here. So after we do that 90-degree clockwise rotation, I would have a shape that would look like that now. Scale factor of 2, it would be the same size, and then I would need to translate it over. So this would be a dilation with a scale factor of 2, followed by a rotation and translation. Whenever we are looking at similarity, we always want to say what the scale factor is. We always want to say what the scale factor is. All right, on the back side now, it says using scale factor. Sometimes we know what the scale factor is and we want to find out what the similar shapes are. So, they have the same shape, but may have different sizes. So the sizes of two figures are related to the scale factor of the dilation. Now, we covered this in the last lesson, but if the scale factor of the dilation is greater than 1, it is an enlargement. If it is less than 1, it is a reduction. And this doesn't happen often, but if it is equal to 1, those two shapes then would be congruent, because they'd be the same size. Multiplying by 1 does not change anything. That's one of the identities. So example 3 here. It says a baker is reducing an 8-inch by 10-inch photo to place the image on a cake. He reduces it by a scale factor of 0.8, then decides that the image is still too large, and reduces it by a scale factor of 0.9. What are the dimensions of the final image, and is the image similar to the original? Explain. So we have two dilations. So we're going to look at the first dilation. 8-inch by 10-inch. And we're going to apply a scale factor of k equals 0.8. So 8 times 0.8 is going to get 6.4 inches. And 10 times 0.8 is going to get 8 inches. So that's what the image looks like now after we do the first dilation. Now, dilation number 2. He decides it's still too big. So now the dimensions are 6.4 and 8. And we're going to apply a scale factor of 0.9. Just because he feels like it's still just a little bit too big. So if we do 0.9, 6.4 times 0.9, it'd be about 5.76 inches. And 8 times 0.9 would be 7.2 inches. Now it wants to know, is this shape similar to the original? Well, let's find out. If they are similar, they should have the same scale factor. So the first dimension, let's do the 5.76. The corresponding dimension would be 8. 5.76 divided by 8 is going to get 0.72, so that's the scale factor for that one dimension. The second scale factor would be 7.2 divided by 10, and that would still get 0.72. They are the same scale factor, which means that they are similar. So yes, because the scale factors are the same, and we can say that k equals 0.72. We could have also found it by multiplying the two scale factors above. 0.9 and 0.8 were the two scale factors. If we multiply those two scale factors together, we would still get down to 0.72, which is also a good way to calculate the scale factor of multiple either enlargements or reductions. All right, this is the end of Lesson 8. If you have any questions, please let me know.